The supply chain and control system sector is increasingly adopting digital and connected technologies. Whilst use of IoT technology within industrial control systems, ICS, has many benefits, they also introduce new risks and challenges, such as cybersecurity concerns. Applications range across buildings, BMS, to industrial, ICS, or transport systems, potentially involving the use of IoT sensors to monitor performance, track objects, or provide data. However, improvements in performance and efficiency increases the scope for attacks aimed at industrial espionage and sabotage. It's critical to design fast and reliable intrusion detection systems robust to changes such as the aging of devices. Challenges being addressed by PETRAS research include: how do we provide security and privacy assurances in supply chains and control systems? How can cybersecurity be addressed separately to, but in harmony with, safety, particularly in safety-critical systems? How might information be shared and used at the edge for risk mitigation? How does policy and regulation keep up with rapid technological change? Logistics 4.0 has designed and developed tiny sensor tracking systems that attach directly to high-value goods and provide environment, transit behaviors, and wide-area real-time location data. Asset tracking optimizes supply chains and logistics operations. Current solutions are expensive, not fit for purpose, and unable to unobtrusively track objects in near real time. Logistics 4.0 worked with partners Tate, the Victoria and Albert Museum, Ordnance Survey, Arm Holdings, the Fine Art Shippers Constantine and Momart, and insurers Blackwall Green to explore several key challenges to securing tiny devices. The potential of using the randomness of information from tiny sensors themselves to generate keys. New insights on the importance of addressing security needs within a system already at its processing capacity. Challenging usefulness of tiny sensors if this cannot be addressed, and exploring the potential machine learning-based solutions. The challenges for risk management, security, and trust when using tiny sensors to monitor high-value goods, such as an artwork, where previously knowledge has been limited and based on confidentiality and secrecy. Including both the security risks of this being exposed, as well as the privacy implications revealing behaviors of people working with the items housing tiny sensors. Though the focus is on high-value goods, specifically art, the AI or systems or algorithms or protocols that operate at the edge not only apply to other goods, but their advances will provide a step change to security/reliability of IoT and cyber-physical systems generally. Elliot. Elliot has developed an AI-based early anomaly detection model. This model can be applied to industrial processes to catch early signs of cyber attacks and thereby prevent catastrophic consequences such as the exfiltration of sensitive data or the disruption of critical processes. The project selected the building automation and control system sector as a use case and developed an industry-standard hardware-in-the-loop testbed for security research at UCL. They tested the performance of this novel approach on datasets, representing scenarios of stealthy and manual and random attacks against their testbed, as well as on other existing datasets captured from real buildings. They published a set of practical guidelines on building machine learning-based intrusion detection systems. This was targeted towards industry practitioners as well as board-level members responsible for making decisions for securing the Internet of Things in control and automation systems. MASS. The MASS project investigated several areas for security modeling that are used to support threat and vulnerability identification, monitoring operations, and countermeasures development, including analytics, at the periphery of the Internet. Best-in-class cybersecurity approaches use a holistic socio-technical viewpoint, moving towards modeling and simulation for testing and securing modern critical infrastructure systems. Given the growing need to address the problem of security risk management in CNIs, M&S offers practical pathways with techniques and tools. It provides a better, evidenced understanding of the realistic usefulness of analytical monitoring, modeling and simulation, as well as highlighting current limitations in supporting improved security from analytics and AI viewpoints. The project published a policy briefing highlighting the importance of adopting cybersecurity modeling and simulation techniques that embody integrated socio-technical factors, and a technical report on the state-of-the-art, application and maturity of socio-technical security models for industries and sectors dependent on CNIs. Explore our expansive knowledge base of cutting-edge socio-technical IoT cybersecurity research findings and over 470 research publications on the PETRAS website, petras-iot.org.